Today we will learn about pressure measurement using YouTube manometer and inclined manometer. What's the difference? YouTube manometer is used for general di- uh, differential pressure or pressure, but inclined manometer is used for very small pressure difference measurement or very small pressure measurement because of the advantage of it having a longer leg. So it makes the reading even more easier to measure the smaller differences. Basically, these two instruments work on basic principle, which is hydrostatic law. As you know, hydrostatic law is P is equal to rho gh. If we know the height difference, then it is delta P is equal to rho gh. Okay. First, we have YouTube manometer. Let's first find out how we will measure pressure difference. Let's assume this is line, and this here we have filter, and I want to know how much pressure drop this filter is creating. So what I will do, I will connect a YouTube manometer. YouTube manometer is basically a U type tube filled with a uh, liquid, which could be any liquid, but if you are uh, measuring a liquid, then you take this liquid always pretty much greater density than the one which is in pipe. Okay, so let's consider like so that's why we usually take mercury, which is highest density, which has highest density. So now I have connected this. Now this in this pipeline the flow is flowing in this pattern. As we know that the flow when any liquid moves, as it moves along the pipeline, the pressure drops. Since there's a filter, obvious there will be obvious pressure drop. So let's say this is P1, this is P2, and the pressure drop is delta P. Well, you have connected manometer, and because of this pressure drop, there will be height difference in this. Whereas a low pressure, the liquid will go up because here there is high pressure, so it will move push the liquid downwards. So the liquid will move and creates a height difference. So this and this difference is created this height. So I mean this pressure and this pressure difference created this height difference. So the delta P will be rho gh as per hydrostatic law. Okay. Now this method is to find out the pressure difference across this filter. Now I just want to find out only pressure. For that, what I have to do? Here I need to take one a reference point. So I will take atmospheric pressure as reference point. Let's say I have this pipeline and it's ended here. Here I connect U2 manometer. One side U2 manometer, I expose it to atmosphere, and since it has higher pressure, it will push the liquid downwards. It and again it creates the height difference. Okay, since on side we have atmospheric pressure, we can directly consider this height created is the pressure inside the pipe. So what will be the pressure inside the pipe equal to rho gh. Rho is density, g is gravity, h is height. So the pressure will you will get, that will be the pressure inside this pipe, but this will be in gauge pressure because the reference point is atmospheric pressure. It will be in the gauge pressure, but however if you want absolute pressure, then you just add atmospheric pressure to this gauge pressure, you will get absolute pressure. Okay, now we will find out about the inclined pressure, sorry, inclined manometer. The only difference we have over YouTube manometer, here YouTube is pretty much simple, but the readings will not be that much accurate because for very accurate you need very long YouTube manometer. So what's the best option? I'll create this inclined, where one leg will be shorter but another leg will be at an angle very extended. Okay, now let's say I have this pipeline and I have control wall in that pipe, and I want to measure the pressure difference across this control valve. What I'll do, I'll connect this inclined manometer. Now again, and assuming that the pressure difference is very less, so from YouTube manometer it will be difficult to find out the exact height difference that pressure drop has created. So I will use this. So what I will do, I'll first, so here it is P1, here it is P2. Obviously P1 is greater than P2, that's why the high pressure pushing the liquid downwards. So the liquid, so on the other leg the liquid will move up. So if so basically I need the vertical height difference between these two points. So what I'll do, first I'll find out this height, then I will find out this height. So if I'm subtract this height from this, I will get the difference. How will I get height, this height? How will I calculate this height? I have this scale inbuilt on that inclined manometer. So I know this angle. Let's say this is 30-degree angle. Then I'll just calculate. As we know that sine theta is equal to opposite by hypotenuse. So this is opposite. This is hypotenuse. So this will be. Uh, I mean, this will be hypotenuse into sine theta, which is L into sine theta. So pressure drop will be rho gh, which is density to gravity to what is h? H2 minus h1. H2 is L sine theta minus h1. Okay, and this is the above one is for pressure difference measurement. For pressure measurement, as I explained you, just take a reference atmosphere pressure as a reference point and do the rest. So what are the application of manometer? Pressure measurement, pressure drop measurement, which is differential pressure, and also using orifice plate you can measure flow also. We have that specific formula to measure flow using orifice orifice plate, which I will explain later.